Welcome back to Algebra 2. This is Unit 3, Section 6, Complex Numbers. Now, before we begin our conversation about complex numbers, we need to have a conversation about a situation that developed in mathematics, which was called the square root of -1. And what that is a number. What was happening was square roots were coming up as negative numbers with the implementation of something called the quadratic formula. And when this was happening, mathematicians were at a loss at what to do. So what was figured out was that we had to come up with what was called the imaginary unit, or I. So I is equal to the square root of number -1, which leads us to know that I squared is equal to -1. So what this allows us to do is to factor out I and then solve for square roots. Okay, so this again is called the imaginary unit, right? The imaginary unit. We're going to use the imaginary unit to work with, going forward here, complex numbers. So, our goal of this lesson is that you can perform operations with complex numbers. So what's the difference between negative square root of 4 and the square root of -4? Well, negative square root of 4 is the same as -1 square root of 4. So we can simplify that as -1 times 2, right? We can solve for the square root of 4 and get 2, and so our answer would be -2. Now this is different than the square root of -4, because you can't take a square root of a negative number. If you plug that into a calculator, you're going to get an error code. So we have to get that -1 out of there. So this would be equal to the square root of 4 times the square root of -1. And as we just talked about, the square root of -1 is equal to I. So we would have 2I. So the imaginary unit, as we said, the imaginary unit is I, which is equal to the square root of -1, or I squared is equal to -1. So the definition of what would be an imaginary number is a number when squared produces a negative number. So how do we do these? Well, what we're going to do is we're going to simplify these square roots of negative numbers as part of our process. So the first thing we do is, if the number is negative, we take this apart. So this would be 3 times the square root of 16 times the square root of -1. Now 16 is a perfect square, so we can simplify the square root of 16. That'd be 3 times 4 times the square root of -1, which is I. 3 times 4 is 12, and I is our final answer. We treat I just like we would pi or a variable. Okay. Next, okay, if you remember, this is a factor. We can factor out a perfect square from 75. So one of the perfect squares that goes in is the square root of 25. So this would be equal to the square root of 3 times the square root of 25, again, times the square root of negative 1. I don't know what the square root of 3 is. It's a radical. And so we can't simplify that. But I can simplify the square root of 25, and that's 5. So this is going to be 5. The square root of negative 1 is I, and this would be square root of 3. Again, we take it apart. The square root of negative 12 we can take apart and say, well, that's the square root of 4 times the square root of negative 1 times the square root of 3. Right? So I know the square root of 4 is 2. I know the square root of negative 1 is I. And the square root of 3 is the square root of 3. Okay. So now we're given 2 times the negative square root of negative 36. Again, take it apart. Don't forget to bring 2 over here. So this would be the square root of 36. 36 is a perfect square, and times the square root of negative 1. So bring it down another step. 2. Square root of 36 is 6. Right? 6 times 6 is 36. If you have to, use a calculator. And the square root of negative 1 is I. So our answer here again is 12I. 1/3 times the square root of negative 63. So this would be 1/3. Well, 9 is a perfect square, so I'll take 9 out. I've got 7 is my other factor of 63, and then the square root of negative 1. So I've got 1/3 times, oops, I don't want that. I don't need that anymore. 1/3 times 3 times I for negative square root of negative 1, and then the square root of 7. So 1/3 times 3 is 1. 1 times I is I times the square root of 7. So complex numbers. Well, complex numbers are made up of an integer, a, or any number, any real number, a, plus or minus b times I, any real number times I. Okay, so under these rules, real numbers are complex numbers where b equals 0. There's no imaginary number then, right? Because 0 times anything is 0, even 0 times I. So b equal to 0 would just mean whatever a is, whatever the real number is. Imaginary numbers are complex where a equals 0 and b does not equal 0. So there'd be no real value. It would just be like 2i, 5i, pi times I, negative 7i, square root of 43i. Doesn't matter. Okay. So two complex numbers are equal if a's are equal and b's are equal, right? If you have the same a and b values. Adding and subtracting complex numbers is similar to adding and subtracting like terms. So to add and subtract complex numbers, combine the real parts and then combine the imaginary. So here's our situation. Okay. So I've got 4 plus 2i plus the quantity negative 6 minus 7i. So the first thing I always do, I'm going to get rid of all of my parentheses. Minus 6 minus 7i. Then you could just rewrite this in order. So 4 minus 6 plus 2i minus 7i. Just got all of my real numbers together and all of my imaginaries. 4 minus 6 is negative 2. 2 minus 7 is negative 5i. I'm done. Okay, when we're subtracting these values, we have to remember to distribute this minus sign. So when I clear my parentheses, so I'm going to have 5 minus 2i minus negative 2, which becomes plus 2, minus negative 3i becomes plus 3i. So now I rewrite everything in order. 5 plus 2 minus 2i plus 3i. Now I just kind of add them all together, right? 5 plus 2 is 7. Those are like terms. Negative 2i plus 3i is plus I, and I would be finished. Now, let's look down here. Again, clear my parentheses. I'm adding though. So 1 minus 3i, I don't have to change anything. Minus 1 plus 3i. Well, 1 minus 1 minus 3i plus 3i. This is silly, this problem, because it's just 0. Okay, what happens if I just have an imaginary number minus a complex? Well, I just clear my parentheses, right? Keeping in mind, just as a reminder, I have to spread this, distribute that minus sign over everything inside. Also, bring my I down here, right? Don't be sloppy. So this would be negative 3 minus, or excuse me, plus 2i minus 5i. So my final answer is negative 3 minus 3i. Okay. All right, so what happens if we multiply them? Well, you can go ahead, we'll write these out, but we have to distribute, right? I'm going to distribute this over this. And let's see what happens. So negative 2i times 2 minus 2i times minus 4i. So negative 2 times 2 is negative 4i plus 2 times 4 is 8. I times I is I squared. Now we're not done here because I squared, we learned, is equal to negative 1. So this is equal to negative 4i plus 8 times negative 1. So our final answer is negative 8, right? The real value goes in the front, so this would be negative 8 minus 4i. Okay, and as I always say, we're going to use distributive property here. So I'm going to multiply this by everything here and here. And I'm also going to multiply this times these two. I find this easiest to do by writing it out. So I'm going to write 3 times 4 minus I plus, excuse me, that's not right, plus 6I times 4 minus I. So 3 times 4 is 12 minus 3I plus 24I plus, oh, excuse me, minus 6I squared. And if you want to, you can always just do this. 6 times negative 1. Right? Because I squared is negative 1. So I end up with 12. Negative 6 times negative 1 is positive 6 minus 3i plus 24i. So my final answer here is 18 plus 21i. Again, again, we're going to distribute. Okay. Okay. So 2 times 2 minus 9i plus 9i times 2 minus 9i. So this is 2 times 2 is 4 minus 18i plus 18i minus 81i squared, right? Which is, again, I can just put that as times 81 minus 1. So this problem now, as we work this out, this is 4 plus 81, and I got minus 18i plus 18i. And this is a very interesting type of problem because 4 plus 81 is 85, and negative 18i plus 18i is 0. We've gotten rid of all of the imaginary pieces of this problem. This is a very special type of problem. It's called a conjugate. And if you'll notice, it looks very, very similar to each of these, except one has plus 9i and one has minus 9i. And so we can almost shortcut this problem, where we can take out, and all we have to do is square the first two values, or multiply the first two together, and multiply the last two together, and we would get our answer, right? 2 times 2 is 4. Positive 9i times negative 9i is negative 81i squared, which is negative 81 times negative 1 gives us positive 81. Add them together, 85. So anytime you have two i's like this, only, like I said, what's nice is I can multiply. Negative 5 times 6 is negative 30. I times I is I squared, which is negative 1. Negative 30 times negative 1 is positive 30. Right? All right. So we're going to talk a little bit about our square root property, right? Because any square root, right? If I take the square root of a value, right? So let's say I take the square root of x squared. Well, that's going to be x, but it's also going to be positive and negative x. So if you think about this in these terms, if I take the square root of 25, well, 5 times 5 is 25, but negative 5 times negative 5 is also 25. So both of those answers are true, okay? If I have just a value where I say, let's say the square root of 9 equals 3, they call this the principal square root. Okay? All right, so if I were to take this and take the square root of each side, so I take the square root of x squared and I take the square root of 25, well, I would end up with x is equal to both positive and negative 5. You see how I wrote that? Over here, I can add 36 to each side. And I end up with x squared equals 36. So if I use the square root property, I end up with x equal to positive and negative 6. Over here, I have to have perfect squares to do this, so I'm going to divide everything by 2. I want to get rid of that. So I end up with x squared minus 16 equals 0. Well, we can take this and say x squared is now equal to 16, and I'm going to take my square root of each side of this, and I end up with x is equal to both positive and negative 4. Okay. So now what we can do is we're going to solve some quadratics with real root properties here. Alright, so now we're going to solve quadratic equations using the square root property with imaginary solutions. Alright, so this first one here, x squared equals negative 81. So we're just going to take the square root of each side of this. So this becomes x. Well, the square root of negative 81 is the square root of 81 times the square root of negative 1. So x is going to be equal to square root of 81 is 9. Square root of negative 1 is I. Alright, so we want to get x squared by itself. So I'm going to divide everything here by 3. Including 0, just to be in that habit, good habit. So dividing everything by 3 gives me x squared plus 25 equals 0. Now I'm going to subtract 25 from each side, and I've got x squared equals negative 25. So we take our square root of each side, and I get x is equal to square root of 25 times the square root of negative 1. And this ends up just being x is equal to, and we can actually do this. Let's get in the habit here. We should have done this here, positive and negative of 9i, positive and negative 5i. Alright. Same over here, square root of x squared, square root of negative 36. This is x is equal to the square root of 36 times the square root of negative 1. So x is equal to both positive and negative 6i. Now, sometimes we may end up with a mixed type of number such as this. So I'm going to get x squared by itself. I subtract 48 from each side. And I end up with x squared equals negative 48. So now I'm going to take that square root from each side. Well, 48 is not a perfect square. So what are the perfect squares that go in? Right? So I got x is equal to, well, I know 16 goes into 48. I can use my calculator to divide that in. And it's 16 times the square root of 3 times the square root of negative 1. So now x is equal to both positive and negative 4. Negative 1 squared, square root of negative 1 is I, and then square root of 3. And technically it should be 4 square root of 3i, but I don't like doing that because I tends to sometimes slip under the square root sign there. So, alright, this one here is a little more complex because 9 does not divide into 25 evenly. But we're going to divide everything by 9 anyway. And maybe you'll see where we end up with this, right? So x squared plus 25 ninths equals 0. So I'm going to take this and subtract 25 ninths from each side, and I got x squared equals negative 25 ninths. So I'm going to take the square root of all that. Well, the interesting thing here is this. Well, now watch. If you remember, x is equal to, this is going to be equal to the square root of 25/9 times the square root of negative 1. Now, one of the things I can do with this is I can take and split it each up, square root of 25 over the square root of 9 times the square root of negative 1. So now when I simplify this, the square root of 25, this is all going to be positive and negative. Square root of 25 is 5. The square root of 9 is 3. Square root of negative 1 is I. I do it in each piece. So that concludes our conversation for what we're going to work with complex numbers. So have a great day. Peace.